Good evening, all. So, in the last lecture, we looked at the remaining operators, not remaining. We looked at two more operators, relational and logical operators. Before that, we already looked at arithmetic and bitwise operators. Remaining operators will be covered in the labs and tutorials. So, today we will touch upon something called operator precedence. So let's start with an example. Suppose I have an expression like, say, 5 plus 7 plus 8. What is the value of this expression? 20. Simple, right? Now, in this, which operation did you perform first, 5 plus 7 or 7 plus 8? Normally, the order in this case doesn't seem to matter. Either way, you are getting the same answer, all right? But let's take a slightly different example. Here, what is the answer? 3. Why 3? Which subtraction are we performing first? 20 minus 15, the leftmost subtraction. Okay. But if you change the order, what answer will you get? If you do this first, 15 minus 2 will be 13, 20 minus 13 will be 7. You're getting a different answer, right? So here the order matters. All right. So even in this case, there is an order. It's just that whichever order you follow, you're getting the same answer there. But that's not the scenario in every case. In the case of minus operator, it doesn't work that way. You have to follow a specific order. Similarly, in other operators also, you have to follow a specific order. Okay. So what is happening here? We are performing this addition first, and then we are performing this addition next, right? Here we are performing this subtraction first, and then we are performing this subtraction next. Okay. So we are getting the answer 3, right? Let's take one more example. Say 20 by 8 into 4 plus 6 by 3. What is the answer for this? Huh? 12. Imagine this is not regular mathematical thing. This is to be coded in the computer. So when you give this expression to the computer, what will be the answer? 10 or 12? Why 12? First, which operation is performed? 20 by 8. What is 20 by 8? 2.5. That is the answer? 2 or 2.5? 2, because this is integer division. In integer division, the output is an integer, not a real number. The quotient is the result. 20 by 8, quotient is 2. So this will be 2. 2 into 4, 8. And then should I do 8 plus 6 and then divide by 3, or should I first divide 6 with 3 and then add it to 8? Divide 6 by 3, that is 2. Add it to 8, you will get 10. Okay. So the answer here is 10. So what is the order of operations? First, this is performed. Then this is performed. And then this division is performed. And finally, this addition is performed. Right? So why division and multiplication are performed before addition? Okay. Yes. BODMAS rule. So basically, there the idea is among operators, there is a precedence. Some operators have higher precedence. Some operators have lower precedence. So division and multiplication always have a higher precedence than addition and subtraction. This we all know. Okay. Now so within division and multiplication, is there a hierarchy? Is there a precedence? Division. Okay. So let's slightly modify this. 4 into 20 by 8 plus 6 by 3. So which operation will be performed first? 4 into 20 by 8, but within this there is a multiplication and there is a division. Which operation will be performed first? 20 by 8. Okay, then this will be 2. This will be 4. I mean 2 into 4, 8 plus 2, 10. 10 should be the result, right? Okay, so let's try. both these expressions in the system and see. Okay. So just one suggestion: whenever you write the code, try to make it look neat. Whenever you start a block, whatever code is there inside that block, indent it a little to the right. Don't put everything in the margin. It is difficult to read. The more blocks you get, the more difficult it is to read. So whenever you start a block, indent the code inside the block to the right a bit. Okay. So that's a good habit of writing. In C, it doesn't matter whether you indent or not. But as you know, in Python, indentation is the key. You don't have brackets, right? In C, indentation is not necessary, but for readability, it is important. Okay. So first, let me give this expression 20 by 8 into 4 plus 6 by 3. Then let me give the second expression 4 into 20 by 8. Okay, these are the two expressions. So expected answer is 10 for both. All right, let's see. Is anyone thinking we'll get a different answer? Okay. 4 into 20 will be performed first, and then that will be divided by 8. So 80 by 8 is 10. 10 plus 2 will be 12. So you are thinking it is 12 for the second expression. First expression is 10. How many of you are thinking second expression is 12? Yeah, raise hand. What is that? How many of you are thinking second expression is also 10? Because division is performed first. Okay. If multiplication is performed first in the second expression, then you will get 12. If division is performed first in the second expression, then you will get 10. Right? Let's see what we will get. This is either 10 or 12. Two options. We got 12. Why? Division is not performed first. Multiplication is performed first. Sorry? Computer knows BODMAS rule. But you don't know BODMAS rule in the sense you misunderstood it. I will come to that in a minute. In BODMAS rule, it does not say division is greater than multiplication. I'll come to that in a minute. Just give me a minute. Okay, so this is clear. In this case, multiplication is performed first. So whichever out of division and multiplication, whichever operator came first, that is being executed. If division comes first, division will be done. If multiplication comes first, multiplication will be done. All right. Okay. Let's take just one more example. So this is not the right answer. Here 12 is the right answer. Okay. So one more expression, 20 plus 5 into 4 minus 8. What is the answer? Huh? 92. 32. This is straightforward. Only multiplication has a higher precedence. So this will be performed first, then addition because it came left, and then subtraction. Okay. So there are two things. One is precedence. Different operators have different precedence. Some operators have same precedence. Plus and minus sort of have same precedence. If plus comes first, you will perform plus. If minus comes first, you will perform minus. Okay. But if plus and multiplication come first, you will always perform multiplication. Independent of addition comes first or multiplication comes first, you will always perform multiplication. Because multiplication and division's precedence is greater than addition and subtraction. But within multiplication and division, they have same precedence. Whichever comes first, you will perform that operation first. Similarly, within addition and subtraction, they have same precedence. Whichever comes first, you will perform that operation first. Okay. So there are two things. One is precedence. Second is within the same precedence operators, which one should you perform first? Whichever comes first on the left, you perform that first. So you go from left to right, whichever comes first, you perform that. This is called left to right associativity. Like in this case, 5 plus 7 plus 8. You are first performing 5 plus 7 because it came first from left to right. So within operators of the same precedence, be it the same operator or some other operator of the same precedence, either it is plus plus, they are identical, so they will have same precedence, or if it is plus minus, they're different, but they have same precedence. So when operators have same precedence, the next deciding rule is associativity. So some operators have left to right associativity, some operators have right to left associativity. Can you think of an operator which has right to left associativity? We touched upon that. We didn't spend much time on that. Where we first calculate the rightmost expression, then calculate the next left expression, then left expression, and so on. No, not right shift. We looked at an example already. That operator is not, I mean, I just touched upon that. I didn't cover it. Yeah. No, logical operators also are from left to right. Okay, let me give you the answer. Assignment operator. So if I write x equal to y equal to z, what will be performed first? This one or this one? Right side one, right? So first this will be performed and then this will be performed. So first z is mapped to y and then y is mapped to x. So instead of z, suppose if I have 2 plus 3. So this 2 plus 3 value is 5. This 5 is assigned to y and then this 5 is again assigned to x. So the rightmost assignment operator is performed first. So here you come from right to left. Okay, you don't go from left to right. So there are some operators which have left to right associativity. There are some operators which have right to left associativity. The operators which we know, most of them have left to right associativity. Arithmetic operators or logical operators. We will see more examples. Okay, but within that, so the point here is 3 operators, that is multiplication, division, and modulus also. Okay, all of them have higher precedence than addition and subtraction, right? So these 3 have a higher precedence than addition and subtraction. These 3 as a group. Now within this group, how to resolve? That is, all of them have same precedence. And how do you resolve it? Left to right associativity. Same in the case of addition and subtraction also. Addition and subtraction also have same precedence and they have left to right associativity. Okay, so there are 2 things which you need to keep in mind. Whenever you have multiple operators, first classify them according to their precedence. These operators have a higher precedence than these operators. Again, these operators have a higher precedence than these operators, and so on. Now within this group of same precedence operators, check whether they have left to right associativity or right to left associativity. Based on that, you calculate. Okay, so now let's come to BODMAS rule. So this is BODMAS rule, right? Which you all know. Okay. So according to this, if you notice carefully, there is a color coding. All right. So here, what is it saying? Suppose this is one set, this is another set. These 2 together have the same precedence. Then these 2 together have the same precedence. So 1 is greater than 2 is greater than 3 is greater than 4. But within 3 and 4, you have same precedence operators. You have division and multiplication, they have equal precedence. Similarly, within 4, you have addition and subtraction, they have equal precedence. So the simple way to resolve it is whether you have left to right associativity or right to left associativity. In both these cases, you have left to right associativity. So within these same precedence operators, whichever comes first, you perform that. If division comes first, you perform division. If multiplication comes first, you perform multiplication. So division is not greater than multiplication. Okay, so that's what this diagram is saying. Division and multiplication have same precedence. That's why they are like one block. Okay, they have the same color, which means they have same precedence. So whatever you thought of as BODMAS rule so far, that is wrong. Division does not have greater precedence. It's just that they are one group. That's it. It can even be called bombed as anything, whatever it is. Okay, so you can interchange division and multiplication. So D and M order doesn't matter. Similarly, A and S order doesn't matter. All right. Okay. Now, so these are what? These are only arithmetic operators, and even BODMAS rule does not cover modulus operator. So where does modulus fall in this table? Along with division and multiplication. Okay. So you can say another M. So that is modulus. So this has the same precedence as division and multiplication. Again, left to right associativity. If you get modulus first, perform that first, or division or multiplication, depending on whichever comes first from the left side, from left to right. Clear? Simple, straightforward. All right. Now, what about other operators? Relational operators, logical operators, bitwise operators. They will also have a precedence. They will also have an associativity. And when you mix different kinds of operators, arithmetic, relational, bitwise, all these things, then how do you decide? Are arithmetic operators having a higher precedence than bitwise, or bitwise are having higher precedence than arithmetic or relational or logical? We need some clarity on that, right? So we need some rule like BODMAS there also. But we don't have a simple rule there. We have a detailed chart of all the different kinds of operators, their precedence, and among the same precedence operators, whether they are left to right associative or right to left associative. So let me show that chart to you. All right. So okay, so if you look at this, so this block of operators have higher precedence than this block of operators, and they have higher precedence than this block. They have higher precedence than this block of operators. Okay, so one block of operators, all of them have the same precedence. So for instance, like you see here, multiplication, division, and modulus, they have same precedence. And as a group, they have higher precedence than addition and subtraction. Okay, so within this group, how to disambiguate? That is left to right associative. Within plus and minus, how to disambiguate? They are left to right associative. So whichever comes first among this set of operators, perform that first. All right. So you got all different kinds of operators. Some of them we didn't discuss yet, like these round brackets you already know. Brackets have the highest order. That's what BODMAS also says. So when brackets are given, there is no confusion. It's clear which one to perform first, which operator to execute first. But when brackets are not given, then you need this table, right? When you have square brackets, that will be covered later when we cover arrays, and dot operator and arrow operator, that will be covered when we get to pointers, and postfix and prefix, increment, decrement operators, that will be covered in tutorials and labs. All right. Most of the other operators we already covered. This plus minus here is different from plus minus here. This plus minus is unary plus and unary minus. Okay. This plus minus is binary plus and binary minus. So unary plus minus have higher precedence than binary plus minus. So if I write something like 5 plus minus 5, what will be done? First, this minus 5 is evaluated, and then this will be added to this 5. Okay, like that. And logical complement, bitwise complement, they have the same precedence as unary plus minus. And type here is the type conversion operators like int or float. In brackets, you are converting some variable to int or some variable to float. Typecasting is covered in labs and tutorials, right? Same thing. And then star, this will be covered when we get to pointers. Ampersand will also be covered when we get to pointers. And then size of, you already know. Okay. So these unary operators, if you notice, they have right to left associativity. All right. So it's like quite simple, no? Suppose If I say plus 5 and then here I put minus, this plus will be evaluated first, right, before I evaluate this minus. Or suppose I write minus of minus 5. So this minus will be evaluated first. And then you apply this minus again to minus 5. So you will get 5. Or if you put another operator, say this logical not. So first this minus 5 will be evaluated and then logical not will be applied to that. So can you tell me what is the result or the value of this expression? 0. Others are saying 5. So then what is the output of this one? This is 5. We know minus of minus 5 is 5. This one is also 5. So what is the answer here? What is the input for a logical operator? Zeros and ones. You need to think like true and false. Okay. So how do you map minus 5 to true or false? Is it true or false? True. Why? Any non-zero value means true. So minus 5 means true. True means 1. So this value is equivalent to 1. Not of 1 is 0. So this value is 0. Okay. So this negation is logical negation. This negation is arithmetic negation. We can have bitwise negation also. This is bitwise complement. Okay. So this minus 5, first you sort of represent it in binary. How will you represent minus 5 in binary? It is an 8-bit integer. If you use integer, then it will use all 32 bits. If you say char, then it will use only 8 bits. So complement of minus 5 in char will be 253. Sorry, 251. 256 minus 5. If you remember, complement of minus 8 was 248. Why? 256 minus 8 is 248. Similarly, complement of 5 will be 251. So 251 you represent in binary and then perform once complement of that, you will get a number. Okay, so that will be the answer. I won't spend much time on this. You need to put some thought. You will get the answer. Okay. All right. So and so on. I can keep many more operators. I can keep a logical not here, or I can write size of and put this entire thing in size of, and then I can say plus plus of this entire thing and so on. So unary operators, you go from right to left. So right to left associativity. All unary operators have same precedence. So whichever operator comes first on the rightmost side, take that first and then keep coming left. Okay. All right. And so on. So there are different operators. Only mistake in this chart is this and. There is no and, two ands here, 2 ampersands. Bitwise and is only 1 ampersand. Logical and has 2 ampersands. Okay. So just keep that in mind. All right. So let's work out an example. So before we work out example, so let me enumerate the steps of what you need to do when you are given an expression. So whenever you're given an expression, first you look at the operators in the expression. You can even sort of write them separately. And once you get the operators, you classify them into higher and lower order operators. So what does it mean? Basically, you look at the precedence of operators and classify them based on precedence. Okay. So once you classify them based on precedence, then what do you need to do? What do you need to classify them on? Operators of the same precedence. What do you need to look at? Associativity. So within same level operators perform left to right or right to left evaluation depending on operator associativity. All right. So among the operators that we saw so far, only 3 kinds of operators have right to left associativity. That is unary. Unary operators we just saw: negation, complement, bitwise complement, or size of. These are all unary operators. They have right to left associativity. So unary, and then conditional, or another name is ternary, and assignment operators have right to left associativity. All other operators have left to right associativity. Okay, so only 3 kinds of operators: unary operators, conditional operators, or also called ternary operators, and assignment operators. Assignment operators we already saw: x equal to y equal to z. Other kinds of assignment operators also have right to left associativity, and unary operators anyway, plus, minus, complement, size of, these we saw, they also have right to left associativity. Ternary operator will be introduced in lab and tutorial. Okay, only these 3 kinds of operators have right to left associativity. All other operators have left to right associativity. So you can see the table again. So this is one unary operators, they have right to left associativity, and then assignment operators equal to, plus, equal to, minus, equal to, these have right to left associativity. Sorry, ternary operator, this has right to left associativity, and assignment operators, they also have right to left associativity. Okay, so only these 3 kinds of operators have right to left associativity. All the others, as you can see from the table, have left to right associativity. Okay, so now let's work out an example. Evaluate the expression, say, so a long expression, let's take a long expression with different kinds of operators just mixed in a random way. So say 6/4 and 5 mod 8 minus 22/7 right shift with 2. Okay, so let me sort of copy this. Okay, now within this, first let me note down all the different operators: division, logical and then mod, and then binary negation, and division again, so I need not list it again, and right shift operator. Okay, so these are the 5 different kinds of operators that are there in this expression. So now let me go to the table and divide them first according to their precedence. All right, so let me, okay, so among these, which operators have the highest precedence? Division and modulus, they have the highest precedence. Okay, so I will sort of group them. Division, sorry, division and modulus, they have highest precedence. And then binary minus, that has the second precedence. Okay, so this has second precedence. And then bitwise right shift, this has next precedence. So bitwise right shift. And finally logical and, here logical and is here, that has the least precedence. Okay, so let's now take this back and put it here. Okay. Okay. So now within division and modulus, what is the associativity? Left to right. Others are anyway single, and even if more than one instance of other operators come, again their associativity is left to right. This also left to right. This also left to right. Okay, fine. Now, so first we need to perform which operation here? Division and modulus we need to check. Okay, within division and modulus, which operator is coming first? This division. So first we need to perform this, and then modulus is coming. Then we need to perform this, and then division is coming again. Then we need to perform this. So this level operators are all covered. Then AND operator. Sorry, not AND. This binary negation. So this we need to perform. Okay, and after this, bitwise right shift. So this will be 5, and finally logical AND. Okay, so now let's perform these operations. So first 6 by 4, what is the value? 1. Good. 6 by 4 is 1. And then 5 mod 8, what? 5. And then 22 by 7, 3. Now what should we do? Subtract what? 5 and 3. 5 minus 3 is 2. And then right shift. So 2 right shift twice. What is the value? Is it right shift or left shift? Right shift. Right shift means what? Division or multiplication with 2? Division. Okay. So for instance, n right shift k is equal to, what is the formula? N by 2 power k. That's it. Similarly, 2 right shift k means 2 by 2 square. That is 2 by 4. So what is 2 by 4? 0. So 2 right shift 2 will be 0. And then what is the next operation? Logical AND. 1 and 0. What is the output? 0. So the value of this entire expression is 0. Okay. So let's test this. So let me comment this. Six by 4 and 5 mod 8 minus 22 by 7 right shift 2. Okay, these spaces are not necessary, but it's just for readability I gave spaces. Okay, so let's run it and see. Just giving a warning, it's better if you have parentheses, but here we don't want parentheses because we are testing without parentheses. Okay, so just ignore the warning and run the code. Answer is 0. Okay, fine. Now this is fine. All right. Now let me tell you something about one more concept. There is something called lazy evaluation. So what is lazy evaluation? Suppose if I have a scenario where I have true or false. I don't know the second argument. Okay, but I know the first argument is true. Can I know the value of this expression without knowing the second argument? What is the value of this expression? True or 1. Okay, so since I know first argument is true and it is part of an OR expression, I don't need to look at the second argument. Whether it is true or false, the whole expression will be true. So the second argument will not even be touched upon. the second argument will not be evaluated. It will not be executed. You can have any expression in the second argument. It will not be executed because whether you execute it or not, the final answer will be true. So why executing it? Why wasting time and resources? Okay. Similarly, other scenario is, suppose I know first argument is false and it is part of AND expression, and I don't know the second argument. But can I know the overall value? That is false, right? So the second argument will not be evaluated in this kind of expression. So this is called lazy evaluation. All right. But the other two cases you need to evaluate. Suppose I have true and something. Do I need to look at the second argument or not? So that has to be evaluated. Similarly, false or something, the second argument needs to be evaluated. Okay. But in these two cases, the second argument need not be evaluated. All right. So let's look at an example. Suppose I say -5 or printf hello. What will be the output? Okay. Output will be 1. Fine. But is 1 the only output? What will be the first output? Hello. And a new line. And then 1. So why? Printf hello's value is what? Hello with a new line. So value is 6. So -5 or 6. What is the value? 1. Because this is a logical OR, it is like true or true. So final value will be 1. Okay. So for printf hello to return 6, it should first print hello. If it does not print hello, it cannot return 6 because then a printf can return only a number which is equivalent to the number of characters it printed. If it doesn't print any characters, it cannot return any number. Okay, so this is what you are saying. Now, will it print hello or not? Will it print hello? Yes. Okay, let's see. It didn't print hello. Why? It's lazy evaluation. It doesn't need to look at the second argument. -5 is already true. So true or something, it doesn't matter. You just stop there. -5 is true. Overall expression's value will be true. So that is 1. Print 1. That's it. Now, suppose instead of or, if I give and, then what will it do? First, it will print hello because it has to evaluate the second expression now. Okay. And this will return 6. -5 and 6 is 1. Okay. So it will first print hello and then it will print 1. Okay. So this is lazy evaluation. All right. Now let us slightly modify just a minute. Okay. Now suppose if I give zero here, all right. So what will it print? Will it print hello? No, it doesn't need to evaluate the second expression. Overall expression's value will be 0. So it won't go to the second expression. It won't go to printf hello. It will just return 0 and it will print 0. Fine. Okay. Now in this, let me keep it like this. I'll just add. So what I'll do, I'll say int n equal to this. The value is, all right. So now, so first what will be printed? Will second printf be evaluated or not? No. Second printf will be evaluated because this is true and something. The second thing also I need to know. So printf hello will be evaluated. So hello will be printed first, and then it will return 6. So 6 and minus 5 will be 1. And then what will be printed? The value is colon space 1. Okay. Now I have another printf statement, n equal to. So here what will be printed? What is n? What will be the value of n? What is the value of n? That is the value of n. You see, make a distinction between output of a printf statement and value of a printf statement. Output is whatever is printed on the screen. Whatever is printed on the screen is not the value of printf. The value of printf is the number of characters it printed on the screen. Okay, make a distinction between output and value. These are two different things. So the output of first printf is hello. Its value is 6. Hello followed by a new line. Its value is 6. And then the second printf output is the value is colon space some number. This is the output. What is the value? Number of characters it printed. So how many characters did it print? So we need to count. You should count space also. Okay, don't forget counting space. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. New line 16. Percentage D is the number. In this case, this number has 1 digit. So 1 character. But if this number has 3, 4 digits, then it will count as 3, 4. You should add that. If it has K characters, add K. Okay. All the percentage D is 1 symbol. This is not what is being printed on the screen. Whatever number you are printing, that is the one which is printed on the screen. So if that number has more characters, you should add those characters also. Fine. In this case, there is only 1 character. So just add that 1. So total 16. So n's value should be 16. Okay. So now tell me the exact output. First, what will be the first line that it will output? Hello. And new line. So next line it will print. What will it print in the next line? The value is colon space. What is the number? 1. And then next line, n equal to 16. Okay. So this should be the output. Let us see. Exactly, that's what we got. Fine. Hello, and the value is 1 and n equal to 16. Fine. Now in place of this one, what I will do, I will say this entire expression, I will add, say whatever, say 125. Okay. So now the value of this expression is what? 126. Okay. Then the value of n will be 18. Okay. Let's see. Because it printed 3-digit number. Earlier it printed only 1-digit number. Okay. Clear? Now let me give one more example. Okay. So let me quickly explain ternary operator. It will be explained in lab and tutorial also, but I'll just quickly explain what is a ternary operator. Ternary operator is like if else. It's like a compact if else condition. All right. So suppose I want to check if I have two numbers A and B. I want to print the largest number. If A is greater than B, print A. If A is less than B, print B. This is what I want to say. So I say if A greater than B, so I will not say print. What I will do, I will say greatest. I'll just have a variable called greatest. Okay. If A is greater than B, then I'll not write entire thing. I'll just write G. G equal to A, else G equal to B. All right. Now this same thing, instead of writing 4 lines, I can simply say G equal to A greater than B question mark A colon B. What does this mean? If A is greater than B, then G will be equal to A, else G will be equal to B. That's all. So you evaluate this expression. If this expression turns out to be true, assign this first thing to this variable. If this expression turns out to be false, assign this second thing to this variable. Got it? So now let's see. I'll say int G equal to A greater than B question mark A colon B. And I will say int A equal to 10, B equal to 5. All right. And then I'll say printf percentage D G. Okay. Simple. G is 10. All right. Now, suppose if I say A less than B, sorry. Okay. Then G will be 5 because A less than B is false. So whatever is the second argument, that will be assigned to G. Okay. So G will be 5. All right. So ternary operator is a compact if else. All right. So you can combine these operators in any which way you want, relational, logical, arithmetic, whatever it is. You just need to refer to the table and first break them into higher precedence and lower precedence, and within the same precedence operators check whether they have left to right associativity or right to left associativity. That's it. All right. Any doubts so far? Clear? Okay. So try, I mean, when you go back, try with some expressions, some complex expressions, try to code them, try to see what value you get. I mean, before you type it and test it, you do it on paper and then test your understanding. Okay, is this the value that I'm expecting and did I get the same value when I code? Okay, then you will understand these better. All right. Yeah. Okay, so let's stop here. So before I show attendance, just a couple of points. I will show the QR code only once. If you are not getting that, you need to come to me with the error screen on Juno app and your ID card. Only then I'll give you attendance. So be ready before I show.